This is the second part of a mock analytics engineer interview led by Nikita. Have a nice time watching.
Let's go to the next part.
Cool, thank you for the feedback. The data modeling. How would you design a data mart to make this data easily accessible for analysts? Your solution should be scalable over time while ensuring that the mart remains the single source of truth for experiment analysis. Good question. Key considerations: performance issues. The current dashboard takes an hour to load, requiring the product manager to open it well in advance of their weekly code meeting. Subscription tier breakdown. Analysts need visibility into experiment distribution across the company's 3 subscription tiers to ensure there are no biases in user allocation. The current query, however, groups all users together, making this analysis impossible. Current query groups all users together, making this analysis impossible. Historical experiment allocation. Engineers need to track how users are assigned to control. Engineers need to track how users are assigned to control and test groups over time. Right now, the query only displays the most recent distribution, preventing them from monitoring allocation trends. Assume that additional raw data source in the data warehouse provide details about users. Additional raw data source in the data warehouse provide details about users and their subscriptions, even if the sources are not explicitly provided in this case interview. Please consider incorporating them into your proposed data model. They want to see trend, meaning that they want to see the historical data change. Analysts need to see the user's subscription information, right?
Let's assume that we have this events data from previous SQL query. We have events, but we don't have in this query a lot of information about users and subscriptions. Let's imagine we have 2 additional raw data sets with users, with subscriptions.
Well, obviously we need to add data from the subscription table so that analysts can see whatever they need to see. And engineers need to track how users are assigned to control and test groups over time. I think that they need to use incremental update so they will be able to see the whole historical changes. Currently, it says they have only the current changes, current events. So I think I would create separate tables for analysts and add to that existing table, existing data source, data smart. I would add subscription. I don't see if they need to see all the trend historical data, if analysts need that.
Yeah, just once again, how many tables would you have? Or you will have just one with all the data, or you will have several tables?
I think I would have separate tables for analysts with the subscription data, so they can analyze users based on their subscription tiers. For engineers need to track basically the trend. I don't know, they need to create some kind of incremental updated process. I guess that right now they are doing just truncating the table and just loading their current updates without having or keeping the previous records. I'm sure that analysts don't need that, but engineers need to create for themselves separate table with incremental update and maybe use some kind of this SCD table. That's all.
So once again, you will have like 2 tables.
Yes, maybe since we are using DBT, we can just get the source from one table and create on top of that source more short table for analysts so they can just analyze and focus on their needs.
How you will build this table?
How I would build? In DBT, there is a feature, right? Incremental update, but to be honest, I haven't done it in practice. I guess it will check the existing tables records using some kind of key with the data from the source, and then load only the part that were updated or that were added newly.
I got it. Yeah, just asking about, yeah, okay, you don't have an events table right now, users, data, and subscription. So you'll join users and subscription, and you'll have one big table in numerous layer, right?
Yes, I think so. What do you think?
I think that, yeah, for example, the first part, yeah, performance issue. The current dashboard takes an hour to load, right? So I was thinking more about like a star schema. As we have, and you mentioned this in the first part, right? You can create dimensions and fact tables. So we have a fact table with, maybe you can just explain me if you're thinking about dimensional modeling, how you will structure it.
From the practice, I can say that when we had an issue with fact tables performance, usually, but I think we should first consider the partitions, indexes on that table. And
good point.
Usually, in fact tables, we mostly focus on dates, and we do create partitions on dates. We do create partitions or indexes in the columns that are filtered often. That's what comes to mind in terms of performance. And also, I had experience to separate snapshot data with the current data. So we would have a separate table for current data and other separate table for the historical snapshot data.
Yeah. Yeah, but once again, I was talking about, yeah, this is a good point that you should mention about improving performance, but once again, about structuring the project. Yeah.
Structure.
One of the options, yes, is to create one big table, but just, yeah.
Oh, okay, got it. So it's fact and dimensions. So we will have like star schema where fact table will have all this transactional data, like meaning measures, like sums, counts, and user information and subscription as a dimensional table that related to this fact and join it via the foreign key on fact table. But to be honest, in practice, I would prefer one big table having facts and all these dimension tables, necessary fields, and just give one big table to the user.
Do you know what are the differences and what are the drawbacks? And
yes, so we had the problems. Of course, you can create semantic layer, especially in Power BI, for example. You can set up all these relationships between fact table and the dimensional tables. Sometimes the relationships might get broken or semantic semantic layer didn't update it, or in Power BI, I don't know about other tools, but in Power BI, we had an issue when using semantic layer don't provide you, so the users will not be able to see the data set, and they don't want to use semantic layer. They just want to like pull the data from table. And for such reason, I had to choose one big table. And a lot of people, as you know, they tend to use Excel. In Excel, they love to download data into Excel and build their own data analysis. So for such reasons, the one big table is a great solution, since in Excel you cannot set up relationship. I guess it's like not like common situation, but that's what I faced in reality.
Okay, good point. How you would tackle the second part, subscription tier breakdown? So the current query groups all users together, making this analysis impossible. How you will just
groups all users together, making this analysis impossible. Current query. I guess that they have like some kind of aggregated data where they don't have any column that would help them separate users based on their subscription. I think that there is also two ways. Either you can rewrite the query on that under that table and add subscription table into this one big table, or you can have facts and dimensions just related to each other. It just needs extra column of subscriptions to identify users by subscription.
I was thinking more about, yeah, it's possible, of course, common thing to do, but I think that creating separate column for facts like events table and two-dimensional column like users and details or subscription details, it's better in terms of performance, right? Because it's denormalized and we don't repeat this data in the one big table, especially with millions of rows. If we have these millions of rows, we won't be able to load it to Excel, right? Or we just need to slice it and just load on the part of the data. I was expecting, I think, to hear. But it's good, yeah, that you mentioned about partitioning and clustering, incremental update that we talked about. And so this we can structure data and then we can just summarize it if we need to specific dashboard and use like summarized data. Because it will be like an hour to load requirement, so we can limit the data for this specific dashboard or summarize it. There will be like less data. Yeah, but I'm also not proficient in data modeling. Guys, Sergei, Maxim, what do you think about data modeling parts in this context?
It definitely, for my case, very much depending on the person who is doing the dashboarding. I mean, I don't know if many companies like doing star schema or anything because it's an expertise which many people don't possess. We have a sort of gold layer, the data mart, which contains data for both like Power BI, and we have an app. So we don't necessarily try to do funds dimensions. We sort of do it by the need. But I know that our Power BI developers still try to sort of break it down into star schema in her Power BI report in the backend. I thought just because it's easier for her to build the metrics, everything that it's built in there. But I guess it's case by case. Yeah, it's a quite a topic.
Awesome, thank you for the feedback.
Thank you.
Star schema would be really good for scalability. And if we like have a new source, we could just add to dimensions, the other features, and go for it. And it would be scalable over time.
Good point. So if we have events data, if we have another data and we already have some users, we can just join and just good point.
Yeah.
I guess if we want to do some sort of slowly change dimension, I think one big table doesn't really solve that issue.
We should drag it separately on some other table.
Yeah.
Cool. Thank you.
Awesome. Yeah. Let's go to the DBT part.
DBT implementation. Next, we will develop a DBT implementation plan based on your ERT. We'll go through the following key aspects step by step. Model architecture and layering. What models should be created and where should they be placed with your DBT project structure?
Let's imagine that we decided to do this dimensional modeling, right? We have a fact table at 2 dimensions, users and subscriptions.
So what models should be created? Where should they be placed with your DBT project structure? What does that mean? Where should they be placed? Oh, okay. With DBT, I would go, I guess, with medallion architecture. In bronze layer, we're going to have the sources as is, one-on-one. On silver layer, I guess the fact and dim tables would go to silver layer, since the fact is some kind of transformation on the data, joins, etc. I don't know what does mean. Where should they be placed with your DBT projects, within your DBT project structure?
So here we are talking about in what layer, what models should we create.
Okay. On
What models?
layer, I will have the sources, and from the source, I will pull and a little bit change the tables and put them into silver layer. For example, I would some kind of little bit of change into silver layer, and then from the silver layer we can build fact tables, I guess, put them in the gold layer as the aggregated data.
Where you will have dimensions.
What I do now is I could leave dimensions in silver layer. I guess it depends on if we're gonna do like star schema, real star schema, or on one big table. Because usually I tend to just give one table with the dimensions and measures in the gold layer with like aggregated data.
If you will use a star schema, what you will do?
Then I would also put dimensions in gold layer, but I guess people can source it from the silver layer. We don't need to copy, keep the data in silver and in bronze. To be honest, I don't know the specifics of DBT, so I think I can create fact table, aggregated fact table, and put it in the gold layer. Since dimension table don't change its structure, we can keep it in the silver layer. I don't see the reason to have it in the gold layer as well, but it will depend on the case and the business needs. If they need, we can pull it in gold layer.
Okay, let's go to the next one.
Materialization type. Which materialization type would you choose, and what are the trade-offs of each option? I don't remember information about materialization, unfortunately.
Let's talk about tables and views. What are the differences in when we should use views, when we should use tables?
Well, we can use views when we want to hide the logic under the table, or maybe...
What do you mean by hide logic?
For example, we want to have different calculations, let's say, or different logic from one table. If you are building like different calculations from one table, you can create views. If it's, of course, not heavy data, since views are not optimized for heavy data. I would use views in case when I just want to give different calculations with a little bit of different logic, or for different slice. For example, I might filter data from the table A and filter it by region or whatever. And for that purpose, I could just use views and provide this to the appropriate user. For example, if I want to basically slice it by some kind of conditions. I don't know, maybe in DBT it's different. What I know about the views and tables is basically the performance issues, right? If it's big data, views might give you a lot of troubles with performance, since it runs all the time when you invoke the view.
Right.
Yeah.
Once again, differences.
Differences? Okay, table has physical structure. It's in the...
It has data. Right?
Yeah, it has data, real data, but view, it's a virtual table. It doesn't have physical data. That's why it will run the query under this view all the time when you invoke it, which will create you a performance issue in case of big data.
Summarize. Table has data and takes storage.
Right.
But once we updated this data, we have data, and when we reference this table, we don't need to use compute.
Yes.
And when for the query, we don't use physical data, but we use compute every time we reference it.
Right. Yeah.
Yeah. So, okay, cool. So we have 3 layers. And assuming that we have 2 types of materialization, views and tables, how do you think you will, at what layer, what materialization view or table should we use?
Well, definitely in bronze layer, it should be table. For,
Why?
I guess, white, because we need to physically storage the data in our data warehouse, since we are DBT uses approach ELT, right? Extract, well, yeah. We need to have like physical data in the data warehouse, so we don't have to spend time for data transfer. Oh, we cannot load data to views. Oh my god! That's why we should have in bronze layer have tables, right? We cannot load data to views. Okay. So in case of dimension tables, maybe we can use views in silver layer. Usually in silver layer, we do a little bit of changes on column names to make them more readable, understandable, and maybe clean some kind of data here. For that purpose, I guess for dimension tables, we can use views. And for the fact tables, we should use tables as well, just because of the performance issues. And also, since we change the logic or we transform the data, we need to load this data somewhere. And that should be table, I guess.
Yeah, so once again, to summarize.
I would use views for not heavy data like dimensions, and where we do like little bit changes on data set structure, on column names, etc. And I would use tables for mostly fact tables.
So DBT works inside the data warehouse. DBT is not referencing on a bronze layer some other sources. right? How it works, we create a data pipeline and it loads the whole data to some raw database, for example. Database that we created just for DBT transformations, we're in source layer or bronze layer, we reference this one-to-one relationship to this raw data that we loaded.
Oh.
Right? So for this reason, the best practice is to use view. There are a lot of tables.
Right.
In most cases, we don't use all of them because we have like, I don't know, hundreds of tables. So it's better to, and we don't reference them a lot, right? So it's best practice to have a view on a bronze layer, right?
Yeah.
For transform layer, I think it depends. If we don't give access to the like silver layer, right? If we don't give access to this layer to our analysts or business, we also can use view or if maybe incremental is also an option, but like kind of materialization in DBT. I think it's also could be view. And for the Mars layer, I think because this data is referenced a lot by and used a lot by analysts and by dashboards and by business, so we should use I think table just to have this data. So this is my assumptions. Let's go to the next one, testing strategies.
Testing strategy. What tests should be implemented and where would you apply them to ensure data reliability? Testing strategy to check the data quality.
We should be confident that the data after the update is in a good quality and that our dashboards have like correct and accurate data in it.
I guess alerts and notifications just to make sure that the pipelines or transformations successfully finished. And in terms of data, I guess depending on the case, we might want to check if there are any null values or if there are any data type issues. Usually I do check, so for pipelines, it's alerts and notifications. If something breaks, you need to get the email or something like that. Data quality might be like different kind of checks. Null value is the like main and famous one. But depending on the business data, I think you can check the data for each case. I don't know. Other than null value, what could be like the dates maybe?
Yeah, you can choose duplicates, relationships.
Oh, duplicates, yeah. Oh my God, duplicates, relations. I don't know, how would you check relations?
Yeah, in DBT we have relations, relationships. So we check if we have two tables with customer ID. For example, we have customers table with all customer ID, and we have events table with this customer ID. For example, there is a new customer, but for some reason we have this ID in one table, but we don't have this ID in another table.
Okay.
We get a notification, something like this.
Okay, cool.
Yeah, so once again, so some alerts and notification for our pipelines, some testing like duplicates, uniqueness, not nulls on a source layer. Maybe on the source layer we can check. Also in DBT it's possible to check like data freshness, so source freshness. Checked based on some fields. It could be like some, when we use ETL tool, we have some ETL load to field that we can just track, or some metadata it checks. Let's not cover this question, so let's just discuss in overall this part, and let's go to the next part later. For this part, so model architecture and layering once again, how it structures in DBT. ETL loads data to some raw database, it loads a lot of table, and then we have separate analytics database for our DBT projects. There we have like bronze layer, one-to-one source that you mentioned, right? So we have some maybe renaming or data converting things, just slight transformation. On the silver layer, we usually have some, I think, big transformations joins, something like this. And on the third layer, like golden or Mars layer, we have final layer that we give access to this business analyst to this layer. For materializations, once again, views should be used on the first layer. On the third, it should be tables. On the transformer, like it depends, could be also used, or some other. So there are some other types of materializations. Incremental is a materialization type. Also, there is like ephemeral type. Ephemeral is not stored anywhere. It's more like intermediate table. It's for like this temporary table, like in between. So if you don't want to use some C complexity, we can put some code to this ephemeral model. Intermediate recalculations, something like that. But testing and strategy, right? ETL,
Sorry,
alerts.
I just want to clarify. You said that in DBT for bronze layer, it's best practice to use views, and in silver layer as well views, right? To reference the raw data.
I think it depends. For the silver, it
okay.
depends. Not always views.
Okay. Thank you. So next, testing strategy.
Testing, ETL pipelines, alerts in Slack. For the source, you can check the source freshness. Also, we have in DBT something like that I used recently. It's data constraints. It checks the data types of the data that we have in our database. If the data types changes, we get an alert or notification, so we don't have this field. If we have additional field, or we don't have. So we specify what data types should be in this table that we load. Some general tests we can implement: uniqueness, not null, relationships, or we can specify a list of allowed
values.
things. Values, right? Or we can write our own tests by using some macros or just built-in packages, some custom tests. And we can add some alerts even in the dashboards, or just some calculations of some important metrics, right? If we have some big changes, we have some reference number, for example. If we see some big changes, some big difference with the reference number of some metric, we can also get an alert, something like this. Guys, Sergey, Maxim, do you have any feedback and your ideas how maybe it's better to use materializations or testing?
I would like to learn more about this materialization, because in my practice, the views are never used in the medallion architecture, but I understand that DBT is a different sort of a beast. I would definitely, we don't build views in our bronze, silver in data lake, but I understand that the DBT works differently. So we do build views when we want to, as Ajan mentioned, to limit, for example, the amount of rows, add a little bit calculations on top. So we usually build them in gold. Overall,
awesome.
For discussion.
Thank you for the viewpoint.
Come back for the third part the next week.